Okay, so today we're actually we're wearing formal attires every Friday. We have to do it. Except next week, I won't be here at my school next week. So if I ever do a lecture next week, I think it's gonna be at the shop. So, okay, we now fully, or rather partially, fleshed out the course for this year. For this course, so we now have solid plan for what to discuss and what to apply. So yeah, since today is a formal attire, I decided to do with a fancy nut. This is called the picada nut, and I learned it from a guy called uh, Patrick Novotny. If you guys want really good necktie knots, you can check out his channel. Great guy, great guy. So, okay, so yesterday I continued my lecture, right, on groups and talked about abelian group or abelian group. I talked about the abelian group. So, which is a group G. Let's see. And equipped with a multiplication operation such that for all AB in G, AB is equal to BA. Because in regular groups, AB is not necessarily the same as BA. So, yeah, this is what sets apart a abelian group from other regular groups. I feel a bit car sick this morning because the bus came in earlier than expected and I had to rush in, so I had to do half of my routine in the bus, so I feel a bit dizzy because I usually don't do anything in the bus or when I'm in a moving car. And if I do move or do something that's brain intensive in the bus, like read or use my phone, I am getting dizzy, so I feel a bit car sick right now, but I'm otherwise fine. Okay, so on the course outline next, I think I'll be making this or posting this. I believe what's next on the course outline is some integration of person theory. So I mentioned this already before. In fact, I applied it in position theory. Person theory is basically just the concept of a person P, which is not necessarily a conscious being, a conscious human being. But rather, P is some union of sets, which I will call alpha, a class of sets rather, or class of subsets, alpha I in some index of j, such that alpha sub I is an element of the universal set of characteristics, which is bold C. Bold C. Okay. There. Bold C. So this is a person actually. And then C is the universal set of all characteristics that described in human. Okay, so it's some abstraction of our characteristics or what we do or sexuality or gender rotation, whatever, what have you. So that's that. It's an abstract object that's a union of open sets from a topology over C now. So now we have C, right? We have our C, it's not the complex numbers. So we have our C, and then what we're going to do is make it a topological space by taking its topology and equipping it with it. So there. Ultimately, our P comes from here. And so there's also the concept of an abelian block, which is basically just a collection of P. So some A, some math cal L, A. And And so we stated that the alpha I inside P is also a set, or rather an element of, or rather subset, or an open set, or coset of an abstract language, L star. Where L star is the set of all possible concatenations of the English alphabet. All finite of the set so all finite concatenations of the set ABC, or letters A through Z. And so this, so that's why. So it's an element of this set here, or rather it could be thought of as a group maybe, or mathematical structure. That. And the reason I want to apply person theory is because, is because when we talk about the Femboy, so math cal F, which is some structure N, equipped with probably an addition operation, or when we talk about the universal set of all femboys, which is our actually universal group of all femboys, it's not N necessarily, but an F, a regular F, we're going to say that this universal set of femboys is actually a subset, but not equal to our universal set of characteristics, or the topological space equivalent to it. So either it's a subset of C itself, or F is a subset of C and its topology. Okay, so, right, so let's do a recap. So thus far, we have a couple axioms. We have the Z of C axioms. So our axiomatic system that we're using for this theory is Z of C. And then we have our axioms from Femboyology. And lastly, which is the Bussy set, Yowie set, and all that stuff. And then now we have the axiom of the universal characteristics. So now we have three axiomatic systems integrated together into this one nice, neat study about femboys. Right? So I find it really neat, really cool that we're able to do this. So maybe, just a little heads up though. Since I've fleshed out the course outline already, maybe might as well discuss it. So, right. So we also want to discuss about abstract languages in concatenation. So that L star that I showed you guys a while ago. So this, we're gonna want to discuss about that and why alpha sub I is an element of it. Okay. And why perhaps C could be some subset of it. So since C is composed of, alpha sub I here, or composed of finitely many or infinitely many A sub I, which are characteristics, right? And these are elements of this, right? Since this is a collection of these elements, it must be a subset of this. Okay? But we'll just touch upon that later. This course might be condensed a bit for the sake of saving time. So, current time, 10 minutes. Okay, so I suppose I can discuss about abstract languages and concatenation. Okay. So what is an abstract language? I'll make it capital so you guys can see. Abstract languages. So what is an abstract language? An abstract language is it's a structure. It's a type of mathematical structure, such as a group. But it has some different properties. So, let me get my notes here. I'll just sum it up for you guys. So, we begin with the notion of a formal language. So formal language, which I will call A, is a set for which there exists a finite set of abstract symbols finite set of symbols, which I will call sigma, capital sigma. Well, abstract symbols. So it can be something that's not entirely the English alphabet. It could be perhaps numbers, or it could be Greek symbols. So yeah, such that A is a subset, but not the entirety of sigma star. Wherein star, of course, is the concatenation operation. And the concatenation operation, as I said a while ago, are all the finite words that we can form from the elements of this set. So if I suppose have a set B, and which is equal to, let's say ABC, and then I want to take its concatenation, this concatenation is the set, well, ABC, CB, CCB, AAB, BAA, ... So all finite words we can form from these three letters, let's say. And when we say word, it's not entirely just, well, literally word like this word over here, but rather it's a string of symbols. So we literally put the symbols next to each other, and that forms a word in mathematics. So when your abstract algebra teacher tells you, well, a free group is a set over, or a group constructed over a set containing all possible words of this set, what he means is that it's some sort of group that contains a set that has all possible words on the elements, or all possible, well, strings of the elements from our original set. So that's what it is. Okay, and let's continue with the definition. Just erase this. Okay. So, a family of abstract languages, or yeah. wrong a while ago, because the thing a while ago was just a set. It's not it's not a mathematical structure in its own. So the L a while ago that I stated, the L star or the A star or the sigma star is not, it's not a mathematical structure. These are just sets. So this is the actual mathematical structure I was pertaining to, abstract family of languages. So I discussed in position theory that we can sort of, we can express the English language, so all English words you can think of, example what I'm saying right now, as some sort of mathematical structure, or it is some set containing all concatenations of, well, all letters of the English alphabet, so A through Z. And that's, well, we can express elements, or rather positions of, well, position vectors, or rather descriptions rather of position vectors as elements of that, well, language, I'd say, which was described as L, right? So here now we have some generalization of that, or higher form of it. So, right, a family of languages is an ordered pair which is sigma capital alpha, such that where one sigma is an infinite set of symbols. So what we mean by this is that the cardinality of sigma is infinite. So it's not some definite value or real number. Because usually if you're given a set and you're asked to take its cardinality, or the amount of numbers in it, we usually get some finite value, right? But here, our sigma, our set of symbols, is infinite. So it can be a lot of things, obviously. So, and then now, capital alpha is a set of formal languages. So, alpha is a set of formal languages. So, it's not only one set of language, which is, well, one set of a formal language, which is our, well, A star, or sigma star a while ago, but rather it's now a set of them. So it's a collection or class of sets. And so for each, so the third condition is very important. For each L, so maybe for all L, inside capital alpha, there exists an infinite subset, sigma 1, such that just a subset of regular sigma, such that L is a subset. Yep. L is a subset of the concatenation of sigma 1. Okay. And then there's a fourth one, it's simple, it's just a simple definition. So L is non-empty. Majority of sets are not empty. If a set is not empty, it's immediately boring because empty set is just nothing. for some, L in capital alpha. So what the fourth condition is saying is that there are going to be some sets in capital alpha that are empty, but not all of them are empty. So there are going to be sets that are going to be like this, but not all of them. So those are the important, criteria for a certain mathematical structure to be a family of languages. So, yeah. If you guys haven't known by now, you guys should definitely study a little bit of set theory for this. Because the third condition is written in the language of set theory. In fact, a majority of mathematics, modern mathematics, is written in the language of set theory. So for all there exists, implications, negate, not, and, or, XOR, stuff like that are used in modern mathematics to describe everything you guys know. Okay. So, let's move on to the main event, shall we? The universal group of femboys. Prepared you guys up to this point. This is why we had to discuss about the abstract family of languages, because a specific case of that is just the English alphabet and the English language. Maybe a specific subset of that abstract family of languages would be maybe Tagalog. Maybe it would be Finnish, or German, but not really, because German or Deutsch contains some characters that are not part of this set. And as I stated in position theory, if you plan on using sigma capital alpha, and you want to sort of describe some or abstract some real life phenomena or name or location or what have you, as you guys just define the abstract family, or rather the set containing all symbols that you want to use to contain those characters, so that you're not missing anything, that you're able to fully describe it or fully abstract it. So, right, so here's when our application of person theory is very, very important, because we will make our first axiom for this theory. And that first axiom, axiom 1. There exists an F that's a subset of the topological space C equipped with its topology. Okay. Such that P sub I in J, which is inside this topological space, is inside F. Okay. And so F, as I said a while ago, our universal set of femboys is a structure which is F, and then an addition operation, such that F is this set over here. Oh no, P. P sub I. P sub I inside I indexed by set J, such that Pi is an element of this topological space. I'm really gonna again, and then close that. Now I know some professors use this notation. Use that to denote such that when you're using set builder notation, but I like using the line because it's more clear and more visible. So I'm going to use that one. So now, what does P consist of? In person theory, well, P is one person, right? And then P contains some family or some collection of elements A sub I. And so A sub I is a part of some abstract language which describes humans. And most notably, that would be C, capital C, or boldface C. So now, we will now define P sub I to be subset AI, or alpha I in J, such that alpha I is inside C. And if it's not clear by now, C is an abstract family of languages now. So, let you say it. C element subset of a family of languages. And so this is going to be the structure or the building where the majority of our theory is going to take place in. Now I picked addition because when we start describing, well, femboys, right, in terms of like states, well, of course we're going to incorporate some position theory in here and use position states to describe these guys. We will sort of diverge a bit, and then we're going to say that we can break them up into some linear combination or sum of two component pieces, right? So like how in chemistry, we can break down a compound into its principal elements, or like how in mathematics, in your elementary mathematics, we can break down numbers into their prime factorizations. Here, we're going to break down femboys into their characteristics, rather a linear combination of smaller, more principal types of femboys, right? Because human minds are exceedingly complex, and it can only be expressed, at least how I see it, as some combination of very basic moral values or principles. So, majority of my theories now are sort of delving into philosophy, but it's all in the name of mathematical playfulness. So that concludes this lecture. I know it's a bit heavy. I know this lecture is a bit heavy, but you guys need to steel yourselves because we're going to be discussing some topology in the preceding lectures, such as, well, not only that, but yeah, we're going to talk about, as I said a while ago, expressing femboys as some linear combination of some smaller principal femboys. And then abelian blocks, that A that I mentioned a while ago. Abelian blocks are collections of people, right? And how we're gonna treat this as some maybe civilian union, marriage or relationship, whether it be monogamous or polyamorous. We're gonna express that in terms of abelian blocks or abelian blocks, or something like that. Okay. And so now, after that one, I'm gonna do a recap, or rather a re-demonstration, or re-proof, or rather, yeah, a new video where I discuss the three very important theorems of this course, or this theory, which is first the Kirov-Argyll paradox, and then next the Stephenson-Maxwell paradox, and Hilbert's femboy. And I believe to conclude the course, we will be talking about F manifolds. Well, C atlases and the boundary of a femboy. So we're going to be talking about donut femboy. So the donut is something like this. A torus, as we call it in topology. It's a torus. So we're going to sort of think of femboys as donuts. It's a bit fun, a bit cute. But also makes our studying very rigorous, right? We're able to correspond various characteristics to R. So when we think of manifolds in an abstract way, we think of them as some sort of topological space that locally resembles Euclidean space. So there is some clean mapping of neighborhoods from this topological space to R. So we can correspond a region of a manifold to, well, subsets of R. So you guys know the real numbers. So 0 plus the infinity minus infinity. So then, and then we can sort of correspond it via some homeomorphism. So that's a manifold. And that's the last thing that we're going to discuss in this course. And so more advanced things such as surgery over a manifold and surgery theory will follow in a higher course, but I don't think I'll be discussing that. Not only because I haven't quite studied surgery theory much well yet, but because it's still a theoretical course. We're not sure if we're actually going to push through with discussing about it. But surgery theory is a very interesting subject because it's literally like we're treating manifolds as people by cutting them and then matching some stuff with them. Later, Chen. So that's it for this lecture. And so yeah, steal yourselves for the next one.
What are you doing?
That lecture. I'll see you later. Yeah, just 5 minutes. Give me 5 minutes.
Okay, see you then.
So expect that we're going to talk about addition of femboys and application of position theory in the next lecture. So I'll see you guys then.